Thank you all for joining us today at the IBC Summit and for joining this session. We're going to talk about multi-hop IBC, the next hop in evolving IBC protocol, so to speak. So just a quick overview of what we'll cover today. So just a brief intro to Polymer Labs. You already may have heard Bo, our co-founder, speak this morning. Just a super quick primer on IBC for those who may not be familiar. And then we'll jump into some of the motivation for multi-hop IBC. What is it? And then we'll switch gears. Wenwei can talk about some of our design objectives and some of the implementation details that we went through when designing and proposing a multi-hop spec. Let's next. So my name's Derek. I work on the protocol team at Polymer Labs. I joined about a year ago, and prior to that, worked about 10 years in Web 2 infrastructure for a content delivery network. And I'll let Wenwei introduce himself.
Hi, my name is Wenwei. My background is distributed database systems and life science before joining Web3. Currently, I'm an engineer at Polymer Labs.
So if I had to kind of summarize what Polymer Labs is about and our mission, as you may see on some of our shirts around here, we're all about connecting the world of Web3, specifically building on the IBC standard and extending it to go outside the Cosmos ecosystem while maintaining security and decentralization as much as possible. Just a very quick overview of Polymer's architecture, and if you stick around for the demo, you can see a lot more details. But essentially, you can think of Polymer as sort of a hub chain that can sit in between a virtual chain that may not natively support IBC and a chain that may support IBC natively. You could have virtual chains on either side, but the idea is here we'll have a virtual relayer that can take, extend packets, IBC packets to a virtual chain, and using Polymer as kind of the hub and adapter to bridge into the IBC world. So let's dive in a little bit. Very quick review of IBC, and then we can look at multi-hop. What is that? So this is similar to a slide that Bo showed earlier, but there's a lot of parallels between the IBC protocol and the TCP/IP stack or OSI model. What we're most interested in here when we're talking about multi-hop IBC is going to be down here at the channel and the IBC connection layer. So just a reminder, IBC connections, you sort of think of them like physical links between networks in Web 2, and IBC channels are sort of similar to TCP, UDP connections in Web 2. So if we start off and start looking at like a network type topology, just very like high level abstract, we can say, okay, we have, let's say 3 chains, and they want to communicate with each other using IBC. We may have 3 IBC connections that connect these chains. But if we add more chains, we can see that because right now IBC is a peer-to-peer protocol, meaning that it connects just 2 chains at a time, pairwise. The more chains we add and add to this network topology, we start to see that the amount of IBC connections required to have full connectivity between all these chains grows quadratically, and so in the order of n squared. So what if we could reduce this to being ON and use a sparse network topology in terms of IBC connections, but still allow IBC channels to be formed on top of the existing IBC connections? So something like this. When we have a chain like A and B here, they can establish a channel for an application or a DApp to talk to a DApp on another chain and actually use the trust that's implied by these IBC connections that are actually connecting these 2 chains. If you first start thinking about this, you might you might approach the problem as in this top perspective. So you could say, okay, we have an IBC connection between each chain in the hop, and we can actually just create channels between each of them and have a packet. These little boxes are packets. So we can have a packet go from a source chain A to D by getting delivered to B, and then getting delivered to C, and then getting delivered to D. And if you saw Phil's talk earlier, this doesn't just happen magically. There's relayers in between here, and at each step, there's a delay introduced. There's complexities that can also arise because if you're waiting for acknowledgements, or if there's timeouts in the middle hops, like what state are you left in, right? Like if a packet makes it here, but not all the way, and times out, like how do you like clean that up in terms of the incentivizations as well? And so where we're, to jump ahead and see a little sneak preview, what we want to do with multi-hop IBC is utilize these IBC connections, but still establish the IBC channel and send packets directly from chain A to chain D. And Wenwei is going to jump into this a little bit. I just want to mention that if you want to look back, there was some prior thinking around this problem that actually started in 2019. You can look up the thinking there, which was more along the lines of this. And Polymer's multi-hop proposal is going to follow the design outlaid here. So we can continue. So to talk about the implementation, I'll hand it over to Wenwei.
Okay, who is excited to see some tech details? Let's dive into it. So here, following our previous research into the existing proposals and the pros and cons, contrast them, and we arrive at these high-level design objectives. So basically, we want to utilize all these pre-existing IBC connections, so there's no extra overhead to any of the directly connected chains. And also, the multi-hop relayer, the relaying operation should be transparent to the intermediate hops. We all know that as a chain maintainer, you all know, upgrading to a new package and put into production, that's not just a one-button push. You have to go through a lot of processes. So it would be very nice so that any of the intermediate chains, they don't need to be aware of a multi-hop channel even existed. You can always leverage the existing connections. And the packet only flows from the previous the source chain to the destination chain. Okay. And here, of course, beyond just delivering the packets, we also to make sure that the packet delivered from the source to the destination chain can be trusted or can be verified. Instead of just trusting the relayers to do the right thing, we should assume anything in the middle could go wrong. So how do we ensure that the proof can actually prove the existence of any key value committed on the source chain? Let's go through the process. So imagine that a user smart contract or Cosmos module or whatever the transaction happens on the Ethereum blockchain, there should be some state committed to the source chain. And we take that as the first initial proof on the first chain. And then for the next step, since there is already pre-existing direct IBC connections, so that means the chain 1 will have a consensus state for chain 0. So that means the consensus state includes the previous client state, which can prove the key value on the first chain. So if we recursively apply this pattern, the chain 2 have a direct connection to chain 1. That means the consensus 1 can verify anything on chain 1. But there is some caveat, which we will dive deeper, that there needs to be some constraint. That means the client update should follow a certain order, but that is something we're still trying to optimize. So it's has the least constraint to the relayer design, so we can make it simpler. And we apply this recursive pattern until the receiver thinks there will be like chain n minus 1. So the chain n can verify the previous chain consensus state and follow all the process, which we will show in the next slides. Can we go? Yeah. And also, conceptually, if you think about, even though all these chains operations, they are asynchronous, but you think of the whole universe state, right? So initially the packet is committed as a key value commitment on the source chain, and then something happened on the next link. Then another consensus state is kind of minted on the next blockchain, and then there's a third one on top of that. You can think this is like a Russian doll style. You're wrapping a consensus state of the previous chain until the destination chain. So let's say the relay relay all the packets and update clients diligently. And how do we verify? So you can think of this as a replay of the previous proof generation process. So the verification needs to make sure that every time we create a channel, there will be a fixed set of connection hops associated with the particular multi-hop channel. That means as a channel maintainer, you would want to make sure that the connection is always the one you have specified. So starting from the verification of the connection hops, and we take in the connection hops, since every chain will have a pair of directly connected chains except the source and destination. So that means they can reload the connection end status and check if the connection is open and if the channel ordering follows the predefined parameters. And then we follow the recursive pattern. From the last chain, from the chain n, the destination chain, we prove that the chain n-1 have the verifiable consensus state. And we recursively go back to the first chain. And at the last step, which is special because the packet is only committed on the chain 0, the first source chain. Go next. And there are some complexity involved into the relayer design as well. So as contrast to the single hop IBC, the relayer only needs to talk to 2 chains. But here, in order to prove that a packet is committed on chain 0 and can be verified on chain n in a trustless manner, a relayer has to do extra work, starting from query the proof of the initial packet commitment, and then go on, update the client state, and then query the proof of the previous consensus state of the first chain, and then recursively apply this operation until the chain n. Then eventually the relayer needs to assemble all these proofs into a single multi-hop proof that is compliant with our multi-hop IBC spec. And then all these wrapped into a single data structure as a transaction message to the destination chain, and which will in turn unwrap, unmarshal the message and apply the previously stated proof verification process. If any of the chain, so in the previous step, if any of the verification fails, the whole transaction will just revert. That means the packet cannot be verified. Yeah, have a question?
Yeah. Do you imagine that in the future all relayers will have some version of this capability, or like just specific relayers?
That's a very good question, actually. This is some of the future work we're trying to do. So, yeah, can we go to the previous slide, please? Yeah, so here we're thinking like appears there's only one relayer, but in the real world there may be multiple relayers competing to getting the fee incentives. So how do we coordinate? And every relayer may get only partial view of the state. There's some ongoing work we're trying to optimize. For example, if the IBC connection between these 2 chains are already updated, the relayer won't be necessary to do some redundant work. Yeah. And on top of the previous stated linked proofs as a verification concern, there are extra security considerations. Like between any of the 2 chains, the client state may be expired or frozen, the chain may be misbehaving, and also the channel may be closed prematurely. Should any of these happen, the packet verification should immediately fail, the transaction should abort. Only none of this happens, and all these verification steps succeed. By then, can we be confident that the packet is indeed committed on the initializing source chain? Yeah, like I mentioned earlier, there are some future work, future optimizations, like the path we described and also Derek shared with us is a fixed path. So that means as a cross-chain app developer, you would want to know which hops you want to route your packets through. But imagine a Web 2 world. If you want to open your browser, go to a website, you don't necessarily want to specify, oh, I must go through these particular routers and I want to visit some websites. Right? You only want to know the source, which is your computer, and the destination, maybe some remote web host. So in the future, we consider, can we introduce a concept of dynamic channel path? That means only specify the source chain and destination chain, and let the relayer and to figure out what is the best path, or even give you options, the average cost or latency, so you can choose from. And also, nothing will happen without incentivization. And how do we incentivize that? For example, if your dApp has high value, I want to relay some high value transactions in a relatively low latency manner. And as a dApp developer or the real end user, you should be able to specify how much incentive you want to attach to this multi-hop packet. And also, in terms of the proof generation, like answered the question earlier, the relayers should not do any redundant work should any of the existing clients is already up to date. And so that all the relayers can compete for incentivization. In an ideal world, everyone is driven by incentivization, and every packet can be relayed securely and timely. And to wrap this up, we have even more in-depth description of the specific PR of the IBC spec, which we discussed with a number of ICF Interchain Foundation teams and get valuable feedbacks from them. And also we have a working version of the IBC Go implementation. It's currently being actively reviewed by the IBC Go team. And also we have several blog posts to show different perspectives of the proof verification and generation. And to get updates on our latest development, please follow our Twitter handle shown here. And last but not least, special thanks to the Interchain Foundation IBC team, Aditya specifically, and from the informal systems team, Anka, who provide lots of valuable and detailed feedback. Thank you. I think we have a few minutes for questions.
Questions?
Yeah.
I have, so when, well actually to Barry's talk earlier, in the case of fungible tokens, your tokens are only fungible with when you took the same path. So how, and I imagine the idea of multi-hop is always a trade-off as when you, right, maybe there's a reason to take the longer path, which you have the minimum security of all the things, it's maybe longer and all these things. So some people might want that longer path for some reason, and others that shorter path for others. How do you see then, in, for example, the case of tokens, they will no longer be fungible. So you kind of need everybody to use the same path, I think. So yeah, how do you choose the canonical path?
Yeah, that's I think a very good forward-looking question.
Yeah.
In terms of whether a channel path, multi-hop channel identity is defined by the specific source and destination, or plus the intermediate connection hops. Yeah. I think that's still an open question. But here at Polymer, I think we're building the foundational layers, so we will leave that option to the dApp developers, so they can decide, right? Yeah.
Can you talk about the difference between packet forward middleware and this?
Packet what?
Packet forward middleware.
Packet forward middleware and this? Yeah, I think like a fee middleware, right? The ICS29 specs you're talking about?
No, I'm talking about a slightly different spec, the Strangelove one, where you send a token from chain A to B, B verifies it, and parses a memo that says to forward it from B to C, and you recursively apply this step. So the relayer is just validating at each chain along the path that the light client state is valid, rather than the relayer verifying them all at the same time, the destination chain.
Are you describing a use case that's similar to our previous, not ours, but the ICF's previous multi-hop proposal? So every intermediate chain will witness the packet, right? You just parse it and get the memo. Yeah. I mean, that's definitely another valid path to how you want to route a packet, or token transfer is just one example, right? You can do any opaque data transfer. I think the difference is, in our use case, we don't burden the middle chains with any extra update. We maintain the maximum backward compatibility. Yeah, you only need to, to incorporate the latest IBC multi-hop support. You only need to support the source on the source chain and destination chain. Any other intermediate chain, they can be maybe on the older version of IBC Go. Yeah, and also I think the application handling logic is slightly simpler, since you don't need to unwrap and make sense of the packet and then relate to the next one. Yeah. Yeah.
Also, if I can jump in here, packet forward middleware, unless it's been changed, was originally only for transfer.
Yeah.
So
Token
it's,
transfer only.
Multi-hop support is for any type of
Yeah.
legacy packet.
Yeah. Thanks, Thomas. Yeah, that's good.
Yeah.
Okay,
Any
thank
other-
you.
yeah,
Oh, yeah,
thank-
question. Yeah.
I guess,
Oh.
this question is sort of answered by Brad's question, but is like the alternative to like the advantage that I see of packet forward middleware just from now, so like not forward looking, is like we are just reusing existing paths. So it's something like when a token ends up wound in the wrong place, then you actually can recurse over like channels that exist, and you get like the fungible, like the correct token. Whereas this, you're introducing new channels, and maybe application developers don't care, but functionally, at least today, they always care. And so, are you guys thinking like the optimization here is like chain A does not have to establish a connection with chain N, or is there like some case
Right.
where like for whatever reason it would be really hard to do that, but like much easier to do this intermediate thing? Like
It may be a function of the economics. Like, if you're a small chain and you just want to have connectivity, like, it may not make sense to establish a direct connection and maintain that channel. So I think like that's part of the equation there. I think like depending on, I think this came up in conversation the other day, depending on the use case, and the requirements for the DApp, it may make more sense to like establish a direct connection to have the lowest latency, like the highest security guarantees, or most, and so there's like a range of security and economic factors that would like play into like where how you picking your connectivity level. Yeah.
Yeah.
And am I, so like if I have like a multi-hop channel, like chain 1 to chain N, am I, like, do I now have fewer clients than I would have in the case where I like have separate like chain 1 and chain N direct connections?
Yes. So that's like related to those initial slides about network topology, because for every IBC connection you have to have a client on each end, and so by reducing those, you just have a lot less clients that need to be maintained. Yeah.
So I don't need a client update for like chain N.
Right. Only for the existing connections, and if those are already maintained, then you may not need to add any new IBC connection to. Yeah. If you connect, and if I think there probably would be some chains that would have, like are sort of the hubs, like as it is today. Like certain chains have far more connectivity than other chains. So, if you're even like tangentially, or like one step away, you may be able to connect to like a very large part of the ecosystem. So.
Yeah. And also our proposed solution would not preclude the possibility of you relay packets directly from chain 0 to 1 to 2. That option still exists, right?
Yeah.
It's just different options, considering of the latency and cost. Yeah.
Mm-hmm. Mm-hmm.
That makes sense.
Yeah.
And sorry, one last question. What is the cost of verifying the proof on the round proof? Is it O of N or is it lower than that?
I think it's ON.
Yeah. Yeah.
But we imagine in a world that the network topology will follow, similar to the Web 2 world, that a very few nodes connect to many chains, but many nodes connect to very few chains. It's like the power law distribution. Yeah.
Yeah.
Cool.
Yeah.
Thank you guys.
Yeah.
Thanks.
This might have been asked, but
Uh,
if you have time for one more, it's like if I'm doing say a token transfer over a connection like this, doesn't that create like de facto information that does now need to like be maintained? The disadvantage originally of like opening the connection is we have to maintain all these clients, but like if I ship a token to a chain that wasn't directly connected to me, there's some mechanism that has to be like maintained there, because there's now like state from like the source chain on the destination chain.
Yeah, I think that's right. Even though our solution is like application agnostic, that means you can relay any packets. We only see opaque bytes, but your dApp still needs to make sense of what the packet is means corresponds to on the source and destination chain.
That's a major problem, especially when we're talking about different standards, different VMs. Right now, the one that is widely supported is protobuf and maybe JSON, but we need to start supporting RLP, API encoding, and other encoding mechanisms so that we can start supporting more chains outside of the Cosmos.
Like you mean the actual packet encoding, as it said? Yeah.
Yes, because that's the whole IBC relies on applications that are connected through channels, making sense of the information that is being relayed through the network topology. And so if we don't share the same standards, for example, Ethereum, like if you were to use protobuf on Ethereum, and we've looked into this problem on Evmos, you'll have to register every single the smart contract would have to register every single message on the codec, the protobuf codec on the Evmos chain. And that's like you're opening a Pandora box there. Not possible. And so opening this, I've been talking to Aditya about expanding specifically for ICA and then the wider Cosmos applications standards, these new encoding standards. And just like a bit of context for hybrid forward middleware and all that. Initially, we're thinking implementing it directly on ICS3 for connections as a multi-hop. So first one connection between two chains and then multi-hop on during the handshake for connections. But I think now with the middleware, it's just becoming part of the application layer. It's kind of interesting how it evolved.
To bring up your point, I was playing around with implementing interchain queries, testing it across different VMs.
Impossible.
I went through a lot of pain doing different encodings.
Because like with interchain queries, right now it's querying the state on the Cosmos, but if you have smart contracts, you need to have the call data for a specific smart contract. So for example, on ERC20 you want to query the balancer of an ERC20 on Evmos directly from osmosis or whatever. You need to send the ICQ data with the call data and the smart contract address that you want to query for that.
Yeah, you'd have to do like protobuf serialization in like EVM, serialize the packet, and then it gets brought back. Yeah, there needs to be some standardizations around there. Although like I wouldn't say that the channel specifications in that, because they're different layers, I feel like are like non-conflicting. Like and to add to your point about like what needs to be stored, the channel definition hasn't changed in our specification. We're just using the existing connection hops field. And now it's just storing an additional, or maybe more than one connection ID versus just a single one. So like the actual state that's stored across the channels, or the channel state that's stored across the chains has not necessarily changed. And the nice thing about this is that like if you allow for dynamic pathing, so at some point if you allow for like multiple channel paths or multiple different, I guess like link connections to allow for that to specify a channel, then you can have a lot more liveness for the channel, and it's like a lot less likely that channel will go away, since like even if one path dies, you can have another path, you can have some sort of governance process for perhaps like introducing new ones, removing them. Now the topology looks more like TCP/IP.
One of the main benefits of Polymer that I see in the future being built is interchain workflows. So like it's a cool concept of DeFi farming, but taking it to the interchain where you can like
I don't know, you start an Evmos and you have an ERC20, you send it to Stride, or you send wrapped Evmos to Stride, it gets converted to Evmos, Stride, liquid stake, and then you use that liquid stake on osmosis, you deposit liquidity, and then you get the LP token, and then you send it to Juno, and then deposit it into a vault, and then you farm, and then it's for all those actions, there needs to be a connection. There needs to be like, okay, what happens if in the middle of the second interchange transaction it fails? What happens? You go through a different route, or do you retry? So all that, yeah, it's like Zapier for interoperability. It's really cool.
Yeah, we built some, sorry, maybe I'm carrying on.
Hey, carry on, it's really, really interesting.
We built a system called Temporal at Uber. Internally, it was like, basically, because you're doing a lot of async things, maybe it feels like in between, like a similar problem. This is not related to blockchain at all. But the nice thing about it was like, you could write code. So we had like a compiler where said, I can write code that specifies maybe 10 different async actions. And this system will guarantee that things will be executed and that failures will be resolved and like handle all the complexities of like failure, retry, everything for you. Also like rewinding like certain actions. So like whatever you write is considered atomic across like all these different microservices, which is like, and then Temporal is a big business now after they spun out of.
And relating certification for that, what happens when it fails, and then having they relay to retry all the time. Like that's very, really, really important.
Yeah. I guess community ideas for people that like folks that want to come into the Cosmos ecosystem and
there's so much to build.
Yeah, there's so much to build. Yeah.
I don't know if this has been kind of like dry run in some way. Was there like an expected latency / this is what you're kind of talking about, like expected time to delivery in a multi-hop transaction?
Well, it depends on each chain's log times.
Yeah.
How much time? How much time you think you need to retry?
Is the relayer getting paid?
Is the relayer getting paid? I'm gonna relay transaction from osmosis.
But that's where relay incentives comes in. We need some sort of like relay incentive model that can make relaying more game theoretic. Because like now, like even looking at like the relay code is just like, yeah, if the connection's about to die, I'll send time update.
So the relay incentivization through fees, that's the first step. But I think MEV.
MEV, yeah.
MEV with a prioritized mempool for IBC packets that allows you to prioritize all these information, especially for interchain workflows across all these farming opportunities.
But I guess just to add to my question, if I understand correctly, if it's like 3 chains, what is it like?
Evmos has 2 seconds, and you have 6, and then you have.
It's each block, 1 block minimum per chain. Is that how they run it?
Wait, and then you need to send the acknowledgement back.
Yes. Well, if you care about the acknowledgement, maybe it's not good.
Well, if you use a smart contract, you definitely care about this. Because then you're like how we're thinking about it on Evmos is you have distributed IBC, which allows these smart contracts to call IBC to other chains, and then you send the packet, you execute an action somewhere else, you call a smart contract on another EVM compatible chain on Evmos, on Cosmos, and you get the acknowledgement back with data on the acknowledgement, and then you execute whatever else afterwards. That's how we were thinking about it in terms of IBC extensions. EVM extensions. And the IBC.
Awesome. Thanks for all the questions and good comments. Yeah.